for this question from the 2018 paper, it's one of those chain reactions again, you will see that there's always one molecule that has a common thread through all these blocks. So if you count here, there's 5 carbons, 5 carbons, and yes, pentyl and ethanoate. So this pentyl is then probably the thing that goes from here because it's also that formed from there because we know that pent means 5, so there's also 5 carbons. So that's the first thing you must check for before you even look at the questions. Figure out what's going on. You can see here from W, reaction 1 to here, there's a Cl that was added. So it's probably going to be addition or substitution. You don't know yet. Then when you go from here to here, the chlorine that was there disappeared. If something disappears, it's always elimination. And because it's a chlorine that disappeared, it's going to be dehydrogenation, not hydrogenation, but there is a hydrogen as well. Dehalohydrogenation, because the halogen is being removed and the hydrogen is being removed, because you can never only remove one at a time. So that's already that. Then if we go from Y to Z, we don't know what's happening there. And also from Z back to Y, we don't know what's happening there. So Z is the one that we don't know about. And then if we go from Y to X, here we're taking adding the chlorine back. So that means it's probably addition or substitution. But if you look at this molecule, you can see that there's a hydrogen missing there. And there's a hydrogen missing there. So if there are 2 hydrogens missing, we know that this is a double bond. So this is going to be pentene. So always figure out quickly what you can from this, because then when you go to the questions, they become easier because you already know kind of what's going on. Sorry about that. Then going from W to here, let's see, they called it reaction 1. Or actually, let's just look at the questions. Maybe I'm doing too much. Define a hydrocarbon. You can all do that very well. Then write the IUPAC name for hydrocarbon W. Oh, we don't know what W is. So actually, the very first question is going to ask us for what's happening in reaction 1. So let's see. Reaction 1, they say Cl2 gas is bubbled through a compound W in the presence of UV light. That's a bell that must go off because you know the only thing that needs UV light to react is an alkane. So this is going to be some alkane. And because we now already know that we're working with pent, we know that it's going to be pentane. It's single bond, so there's nothing we have to add to that. And all you needed to realize is that if we are using UV light, and that's one of the 3 conditions, there's only 3 conditions that you need to know, remember? So UV light is what you need to let an alkane react because they are saturated and therefore they are unreactive. So that's our first answer, pentane. Let's take that away. Then they're asking us for the general type of reaction for reaction 1. When they say general, it's the big name, elimination, addition, substitution. So that when you see the word general, please be careful because they're going to mark you down if you don't follow the instructions. So for general, we already said we are adding something, but it's not addition because we're starting with an alkane. It can only be addition if it's an alkene. So because this was an alkane, which means there were 5 C's that were saturated. Now I'm drawing over my writing. I'm hoping you can see that. So there's 5 C's that are saturated. It means that we have to kick one of these hydrogens out to put that Cl there. So remember, if we're kicking a hydrogen out and replacing it with a Cl, replacing something is then called substitution. So that first reaction will be substitution. Then for reaction 5, let's see what's going on there. For 5, we are going from something that has a double bond because we've already established that there's a hydrogen missing here because each carbon must have 4 bonds. That you should have seen very quickly. So we're going from something that has a double bond to something else. Let's see what they say here. For question 5, they say compound Y is treated with steam and H3PO4. Now, what we do, there's a double bond, so there's we can add something. Remember, if there's a double bond, addition is probably what's going to happen. And so when a double bond reacts, that's you can actually almost guess that one. It is addition, but you should know that because they're saying steam, it means we're adding water. So the double bond is going to open up and we're going to have an H and an OH. So we are actually going to form an alcohol. All right. And it's actually here that there's a hydrogen missing here in the beginning. But as long as you realize that there's not enough bonds around each carbon. All right, so that's addition. Then for reaction 7, that's the one that you should spot easily, and for some reason you don't. We are forming pentyl ethanoate. When you see two words and it's ethanoate, this one should scream at you because it's the only one that's split up in two words like this. That is our ester. So because it is our ester, the reaction is going to be esterification. You write ester and you write ification at the end. So esterification. We're making an ester. Right, so those were the general ones. They should be pretty easy because you don't have to be specific about what's happening. Now, in the next one, they're asking us for the specific type of reaction. Oh, they're actually helping us because they say the specific type of addition reaction. So we're looking for an addition reaction for 3. And we actually already spoke through that one because we know we're adding something. We can see there was no C and there was no, obviously, if there's a double bond, we need to add two things and there's no double C added. So we added a C and we added an H to fill up that double bond. So it's going to be hydrohalogenation because we're adding a hydrogen and a halogen. So it's going to be hydrohalogenation. You have these answers, so I'm not going to write it all out. So that's hydrohalogenation for 10.4. Then for 10.5, the name for compound Y. So here we just have to name it. So we know there's 1, 2, 3, 4, 5. So it's bent. We know there is a double bond, and the double bond comes after the first carbon. So it's going to be pent 1 ene because we put the 1 in front of the ene because that shows the double bond. But you can also say 1 pentene because there's nothing else. You can put the 1 in the front and it kind of sounds better if you go 1 pentene. Both of those will be accepted. Then they say classify Y as saturated or unsaturated. So compound Y has a double bond. So therefore it is unsaturated. So they're just testing your little bit of knowledge there. That, remember your definition. Unsaturated means there's at least one double or triple bond between the carbon atoms. And we have already established that that is true. So it's unsaturated. Then the next one, consider 5, 6, and 7 and write the IUPAC name of compound Z. We already know what it is because we already said if we're adding the water, it's going to be OH. But if you were not sure, let's see. They also say we must, 5 we've already considered. If we look at 6, 6 goes from something that has a chlorine to something to something new. Now, there's only two things that can happen to a haloalkane. Remember, they can form an alcohol, which is the case here. So they can form an alcohol, then it's not in an alcohol medium. So they didn't give us the reaction conditions, but we already know that it's an alcohol from reaction 5 because in reaction 5 we added something and that something was water. And then they said we must also consider reaction 7. So if you look at reaction 7 to form a ester, you have to use an alcohol and a carboxylic acid. So that is the pack name is then going to be, because we know it's bent and it's an alcohol that's going to make a ester, it is going to be pentanol. If you want to, you can say 1 pentanol, but because it's 1, we don't really have to say it. They won't mark it wrong if you don't say it. Then the structural formula of pentyl ethanoate. Now remember, the one that's in the front, if you start with it, so you're going pent 1, 2, 3, 4, 5, then you're going to put an O if it's an ester, and then you carry on with the rest. It could be a straight line, it really doesn't matter if it looks like this. If that bugs you, I can draw it here as well. So 1, 2, 3, 4, 5, and then the O, and then 1, 2. Then what you need to remember is that the one that comes from the carboxylic acid, the one at the end that did already have a double O, is going to keep the double O. So the double O is going to be on this end one, but it must be next to the other oxygen. Now, if you count this, there's 1, 2, 3, 4 already, but this one needs 4 hydrogens. If they ask you to draw a structural formula, you have to fill in all the hydrogens. You're not going to get that many that it's going to waste too much of your time. But please now, I'm not going to do it, but then fill in all the hydrogens as well. And that's as easy as it is for an ester. You don't have to count anything, except for the carbons, obviously. Then they say, write down the number of the reaction that would take place if an organic compound were heated strongly in the presence of concentrated alcoholic potassium hydroxide. Now, this is the one condition that you need to know. If you see potassium hydroxide, sodium hydroxide, any of those, then you must know that we're going to start with a haloalkane. So you're going to have your haloalkane, and the only one that we had here was X. So it's 1, 2, 3, 4, 5 again. And what happens is, if you have a haloalkane, there's two things that can happen. I'm just going to do it so that you can remember. Remember, if we kick out this Cl, which means it's substitution, then we're going to replace it with an OH, which means it's going to be called hydrolysis. If when that happens, we're forming an alcohol. So when we're forming an OH, it can't happen in an alcohol medium. So when we're forming an alcohol, it's not in an alcohol medium. So that one is not what's going to happen. So what is going to happen, the other thing that can happen with the Cl is that it can be eliminated totally, not just kicked out and replaced, but eliminated totally. So we're going to kick out the Cl and the hydrogen, and we're actually going to form a double bond. And remember, whenever you go from single bonds to double bonds, it's called elimination. And that is what is going to happen if you have concentrated alcoholic potassium hydroxide, because then you're not going to form an alcohol. You're actually going to eliminate the Cl and the H, and you're going to still have 5, and that is right according to our diagram as well, because it's 5. I'm not going to, might as well just draw it. And it's very ugly, I'm sorry, but yeah, you don't really need it. But so you can see here, it did give us pentene. So to go from there was only two things that could happen. It was either going to be hydrolysis, but if it was hydrolysis, please remember you cannot have it happen in an alcohol, then it will be dilute. So you'll have something that shows you that it happens in water. Then it will be hydrolysis and you'll form an OH, which works again because we know that this is our alcohol. If it happens in an alcohol medium, then it's always going to be elimination and you're going to form a double bond. And that's the end of that question.